All right, let's start going through this so you guys can say that I'm wrong. So when you have questions like this in your journeyman or your master test, the first thing you want to do is break out all the relevant information and understand what the question is actually asking you. Just like this guy did when he sent a picture of how he went through this problem. Check your DMs, my guy. I'll send you some swag. Now I cut off the other part, but he went through and listed all the tables and how he actually solved this. First step in solving this, we're gonna head to table 430.250 in the NEC for a 15 horsepower motor. We're gonna slide over to the 460 volt column, 21 amps. We're using the 460 volt column because if you read 430.250, it says for 440 to 480 volts, that's the column you use, as well as your other voltages. So for 15 horsepower at 480 volts, it's gonna be 21 amps, or you got one of my cards and you just look at it for 15 horsepower, it's 21 amps. We're gonna write that value down. But this is a continuous duty motor, so we're gonna multiply that times 125%, and that's gonna give us 26.25 amps. That's gonna be our amperage for our branch circuit size that we're sizing to. We're looking for a conductor that's big enough to carry that 26.25 amps. We're gonna head to table 310.16 in the NEC. It's gonna be number 10. I said it was THWN, it's good for 35 amps. Even if we use a 60-degree column, though, we're good for 30 amps. So number 10 is gonna be the size for our branch circuit. So I'll mark down number 10 for our minimum size THWN. Now let's size our inverse time circuit breaker. We're gonna head to table 430.52C1 in the NEC, and we're using a polyphase alternating current motor, inverse time circuit breaker, so it's 250% of our full load current. It's gonna be 250% times 21, because remember, 21 is actually what our full load current is, so that comes out to 52.5 amps. Well, they don't make a 52.5 amp circuit breaker, so we're gonna read in 430.52C1A where the values as determined by table 430.52C do not correspond with the standard ampere ratings and settings as provided, blah, blah, blah. The next higher standard rating or setting shall be permitted. So our next standard size up from a 50 amp is gonna be 60 amps. So yep, we're putting number 10s on a 60 amp breaker, boys. And now we just need to size our overloads. So we read 430.32 for continuous duty motors, 430.32.1 separate overload device. Our temperature rise, remember, we're marked with 30 degrees, so 40 degrees Celsius or less, so we can go 125% of the motor nameplate value. Nameplate value is 19 amps, so we're gonna take that times 125%, and it's 23.75 amps. So the three values that we were looking for, our overloads are gonna be sized to 23.75 amps. We're gonna use number 10 AWG copper THWN, and we're putting that on a 60 amp inverse time circuit breaker. Now, I can already hear people complaining in the comments. I do not care what you think is best practice, what your opinion is, what you would or would not do. I don't care that you've been doing this 87 years and you have 43 master electrician's licenses. This is done according to the National Electrical Code.